Hello class, this is Ms. Martins and we are in Unit 8 Energy. Today's objective is students will be able to calculate the heat transfer during a temperature change. Before we get into that, I would like to review what a heating curve is. A heating curve graphically represents the phase transitions that a substance undergoes as heat is added to it. So we're starting out with a substance in the solid phase, and then it reaches this point of heat of fusion where the temperature does not change. As we add more heat, it'll finally change into a liquid, and then it reaches into the segment where it's called heat of vaporization, and finally, our substance is in the gas phase. So this is just a general overview of the heating curve. If you would like a more specific overview of the heating curve, you can go back to the heating curve video that I've previously done. Today we're going to be calculating heat transfer, and in order to do that, you're going to need a calculator and your reference table, specifically table B and table T, which is found on page 1 and page 12. The formula that we're going to be dealing with today is Q equals MC delta T. Within this formula, the Q represents heat, M represents the mass, C represents specific heat constant, which is specific for different materials. We're going to usually be working with water, which I'll explain in a few. And then the delta T represents the change in temperature, which is T final minus T initial. The final temperature minus the initial temperature. And these, the values can be represented. You can find them on table T. It's very specific there as well. Q MC delta T is used during changes in temperature. Just to go over the formula again, Q equals heat, quantity of heat, aka energy. The units is joules. M is mass, C is specific heat, it's specific to specific products, such as water, and delta T represents a change in temperature. A few key ideas to note is if a substance receives heat and experiences an increase in temperature, then Q is a positive number, and delta T is a positive number. If a substance loses heat and experiences a decrease in temperature, then Q is a negative number, and delta T is a negative number. We're going to see these two bullet points when we go over questions, and I'll make sure to note it again then. Q, which is heat energy, can be measured in either joules or calories. Just make sure that your units for C, the constant, are consistent with your units for Q. And same for delta T. Delta T, change in temperature, can be measured in Kelvin, Celsius, or Fahrenheit. Just make sure that the units for C are consistent with your units for delta T. So just make sure that all your units are the same so that you can plug it in to the formula. So going back to the heating curve, what line segments on the graph are Q equals C delta T applicable for? So where will we be using this on our heating curve? And the answer is between segments A and B, C and D, and E and F. So I'm going to explain that again. The temperature is actually changing during A, B, C, D, and E, F, as you can see with the slope increasing. However, from BC, which is the phase changes, and DE, which is another phase change, the temperature remains the same. So once again, Q equals MC delta T will be used during A, B, C, D, and E, F segments, and the heat of fusion formula will be used through the BC segment, and the heat of vaporization formula will be used during the DE segment. So let's compare the heat of fusion and heat of vaporization versus Q equals MC delta T. One similarity between them is they both measure heat. Another similarity is they both depend on mass, which you could see in the formulas for all of these equations. One difference is that H of F and H of V measures heat in change of phase. So remember, the temperature is constant. So we're just measuring the heat due to change in phase. And MC delta T measures heat and change of temperature. So based on a change in temperature, what is happening with the heat? So how do we calculate this? We're going to be using table B and table T in order to do so. The specific heat capacity is given to us on table B, and the formula is given to us on table T. The formula that we're going to be using to measure temperature change is going to be Q equals MC delta T. So let's go over a couple of problems, and this is going to make all of this information make more sense and tie it together. This question states, calculate the amount of heat needed to increase the temperature of 250 grams of water from 20 degrees Celsius to 46 degrees Celsius. So we know that we're going to be using Q equals MC delta T because we see a temperature change. That is the first key. Now, in answering questions like this, what I recommend is writing down all the values that you have and what you do not have. So with this question, we're looking for heat. So I'm going to say Q is equal to question mark. The mass is 250 grams, which is given in the question. C is a specific heat constant, and usually the questions that you're going to be dealing with is going to be for water. But if they ask you about the specific heat of iron, they're most likely going to give you that constant within the question. So the specific heat capacity of water in the liquid phase is 4.18 joules per grams per Kelvin. And make sure you take note of these units because it's going to have to be consistent with all the other units in your question, in your equation. And the delta T is going to be 46 degrees Celsius minus 20 degrees Celsius equals 26 degrees Celsius. And the T final was 46 degrees. That's why I put that first. T initial is 20, which is why I put that after. And when you subtract that, you get 26 degrees Celsius. I can put 26 degrees Celsius into my equation because it cancels out. This is just a change in temperature. It's not one specific temperature. So we can use the degrees Celsius in this equation. After I plug everything in, I multiply 250 times 4.18 times 26 degrees Celsius, and I get an answer of 27,170 joules. Please ensure that you get this answer. If you don't, please let me know. It could be my calculations as well. So just make sure you reach out. The next question states, when 15 grams of steam drops in temperature from 275 degrees Celsius to 250 degrees Celsius, how much energy is released? So if you can recall from the previous bullets that I mentioned, if energy is being released, then you're going to assume that your Q is going to be negative, right? So let's see how this works with answering and plugging and chugging this equation. So we're looking for the Q, which is the heat energy. M is given to us is 15 grams. C is going to be the specific heat of water because we're talking about steam, which is 4.18 joules per gram per Kelvin. And the temperature is going to be the T final, which is 250. That's how much we ended up with, minus 275. And that's going to give us negative 25 degrees Celsius. Remember, the formula for finding the change in temperature is going to be T final minus T initial. This is very important in order to get your answer. And then, when I plug that in, we're going to multiply 15 times 4.18 times negative 25 degrees Celsius, and you're going to get Q is equal to negative 1,567.5 joules. And for our final question, try to see if you could pause the video and do it by yourself before continuing on. It states the temperature of a water sample changed from 10 degrees Celsius to 20 degrees Celsius. When the sample absorbs 418 joules of heat, what is the mass of the sample? So we actually know the heat here and we're looking for the mass. So this is going to be a little different from the questions that we did prior. The Q is equal to 418 joules. We don't have to find the heat in this question. They gave it to us. The M is what we're looking for. We're actually looking for the mass within this question. We're talking about water, so the specific heat is going to be 4.18 joules per grams per kilograms times kilograms. And the change in temperature is going to be T final, which is 20, minus T initial, which is 10, to give us 10 degrees Celsius. So you're going to plug into your formula. 418 joules is equal to X, which is the mass, times 4.18 times 10. I'm going to multiply 4.18 times 10 to give me 41.8. And then I'm going to divide the 41.8 on both sides. 418 divided by 41.8 is going to give us 10 grams, which is going to be our mass. So that's all for today. All you need to do now is to complete the Google form entitled Q equals MC delta T practice. If you have any questions, email me or write in the comments of the Google Classroom. Stay safe and be well.